result obtained by rotating the region in example 6a about the line x equals 1. So we talked yesterday about when you didn't rotate by an around the axis, then the radius wasn't just the curve anymore. So we had to think about it a little more. 6a, what was our function? I forgot. Just between y equals x and y equals x squared. Okay, so we found out yesterday those met at 0 and 1. Equals x squared fell underneath that. Okay, if I rotate it around x equals negative 1, so that is a vertical line at negative 1. This is where I should have Bryson come up because I discovered yesterday his illustrations are much better than mine. I'm going to attempt it. So I always just draw the reflection first. We're looking at this piece. And so when we rotate it, then we're getting a bowl. All right. So we know our volume is the integral. We have to decide from where to where. In general, we said if we were rotating around the x-axis, that was a horizontal line, we did it in terms of x. If we rotated around the y-axis or a vertical line, we did it in terms of y. So since x equals 1 is a vertical line, I would do this one in terms of y. My lowest y value, 0, and our highest y value is 1. Okay, and so then we have to do pi times our area, and we're working in terms of y, or times our radius. So, the first radius, if we're working in terms of y, okay, our radius, we're looking for the outside one first. Right. So we need to find an expression for that. It's starting at negative 1. And then to get the distance over here, what would we have to do? And you got the square root of y just by solving this. Now, could you have flipped this around? Made it, the square root of y minus negative 1. We're going to square it anyway, right? So it doesn't matter. Distance between two things, it's the absolute value of what you get when you subtract them. Since we're squaring it, that takes care of the absolute value piece. All right, so that's the outside radius minus the inside radius. So that one starting at negative 1 and going to y. So if I multiply this, remember that would be like FOILing, so you would get 1 minus 2 radical y. Sorry, plus 2 radical y plus y. I would get 1 plus 2y plus y. If I distribute my negative and combine my terms, 1 and negative 1 cancel. we are left with a 2 radical y plus y minus 2y would be minus y squared. Is everyone with me to that point? No, we just didn't. So 2y squared, that's like 2y to the 1/2. So antiderivative, if you add 1 to the power, that's 3/2. So that means you need a 2/3 in front times the 2 that's already there would make it a 4/3 minus antiderivative of y, so that would be a 1/2 y squared minus antiderivative of y squared would be 1/3 y cubed. So I put in my on. So 4/3 minus 1/3 is 1, minus a half is 1/2, times pi, it's just pi over 2. Example for today. Let f of x equal 5x and g of x equal x squared, and R be the region between the graphs of f and g on the interval 0 to 3. So we're not even looking for their intersection points. We know we're just going from 0 to 3. Okay, so 5x is just a line. You can make it as accurate as you want. So if you put in 0, you get 0. If you put in a 3, you're going to get 15. So I only need this portion of my line. Okay, x squared, 0 squared is 0. 1, 1, 2, 4. 3, 9. So we're getting part of a parabola there. All right. We want to take the region between those and revolve it around the x-axis. So this is my solid. When we rotate that, we're getting like a funnel shape. Okay. So to set this up, am I doing it in terms of x or y? X. And I already told you the x's, it's starting at 0 and ending at 3. We said in terms of x, so it's a dx. So we need pi times the radius squared. But because there's an outside and an inside, we have to do outside radius squared minus inside radius squared. So the outside radius, if we take a cross section, okay, we're getting this washer or donut shape. It's going to just go from 0 out, so it's just the function. So my outside radius is 5x minus the inside radius is just to my parabola. So that was x squared. Antiderivative of 25x squared is 25 thirds x cubed. Antiderivative of x to the fourth is 1/5 x to the fifth. Okay, if I plug in a 3 cubed is 27 divided by 3 is 9 times 25. So we get 882 pi. Okay, are we feeling any more confident in these? Rounding to.
Hmm?
Do you have a question?
Oh, no.
All right, so the rest of the class, you have to finish that handout you've been working on. Strongly recommend checking your answers. Unfortunately, there's a lot of places to make a mistake here because they're longer problems. So if you do have a wrong answer, don't erase everything. It's probably a pretty minor mistake that we just need to find and fix. And I'm happy to help you do that.